So lab number 3 consists of mineral properties. We're not going to identify minerals this week. What we're going to do is we're going to look at the tools you need in order to identify minerals. So we're going to look at the physical properties of minerals, and those properties are what you're going to use to basically identify minerals. So we're doing lab number 3, mineral properties. And this lab starts off with the definition of a mineral being naturally occurring, inorganic, crystalline, chemical composition, and that some elements can be minerals and some compounds. Most minerals are made from compounds. That's 2 or more elements. So what are the physical properties? Really basic things like color, streak. Streak is basically a mark that is left on a piece of tile. Luster means if it's earthy, does it look like dirt? Is it vitreous, shiny or not? And then metallic. Good example of something that is metallic that we see every day are coins. So change that you receive, oh, maybe not so much anymore. There's a change shortage. So a good example of a good metallic mineral is gold, silver, copper, chrome. Those are good examples of metallic. Then we'll look at hardness. So basically hardness is on a scale from 1 to 10. The most hardest substance known to humans right now is a diamond, at a number 10 on the scale of 1 to 10. We'll look at density, that is how heavy the mineral is, the specific gravity. We'll look at crystal form with respect to the external expression of the mineral, the shape, hexagonal, cubic, flat. Cleavage. Minerals that break along a flat plane or a shiny plane have cleavage. They often generate shapes, and we'll see some of that, so cleavage. If you don't have cleavage, then you default to fracture. So what is fracture? A random break, the absence of cleavage essentially. And then we're going to look at the unique properties of minerals. So we're going to look at the very unique properties of minerals. Within our lab manual is the Mohs hardness scale. So this rates minerals on a scale of 0.5 to 10. The softest minerals are things like talc, which they make soapstone, graphite, which is in the end of a pencil, and then the most hardest substance known to humans right now is diamonds. And diamonds are basically a pure form of carbon. So we're going to use all of these 10 physical properties. We're going to go through those. And so in order to speed things up, not to bore you with watching a long video, I went ahead and I recorded each one of the aspects of the lab here. So the first part, color. I went through and I recorded all the colors of all the minerals that we're going to see. Second part, streak. So I went ahead and took a streak plate. I rubbed the mineral across every one of these streak plates. If you want to watch me do that for 20 samples, you have a lot of time on your hands. So streak is the color that's going to be left on a streak plate. Luster. Is the mineral dull? Is it earthy? Looks like dirt. Is it vitreous? Does it have a vitreous shine? And so we'll look at some of these aspects. And then metallic or non-metallic. As it turns out, most minerals are non-metallic. So it's very rare to see metallic minerals. If you look at all the 2,000 minerals, 4,000 minerals that we know of today, I would say less than 2% of them are metallic. And then we're going to look at the aspect of hardness. And so the scales that we're going to use for hardness here are simply this. We're going to look at how hard the mineral is to things around us. So fingernails, a copper plate, a glass slide, and a file. So these are some of the tools that you use when you start identifying minerals. It's good to have a bottle of hydrochloric acid. This is very dilute. A file, a copper strip, and a streak plate. We're also going to look at density, how heavy something is. So what I did is I weighed all of the samples out on the scale, and I'll show you that. Then we're going to look at crystal form, the external expression of a mineral. And then I recorded the minerals that we're going to look at, 21 through 26, in their crystal form. Then we're going to take a look at cleavage. So cleavage, remember, is a mineral that breaks along a flat surface and a shiny surface, and it often forms geometric shapes, and we'll see some of those. And then there are properties that are very unique to minerals. So record these numbers, and these are very important. One looks like, has a rust look to it. One of these minerals is going to be magnetic. One's going to have a salty taste. One's going to react to hydrochloric acid. One's going to react to hydrochloric acid when you break the surface or scratch it with a file. One feels soapy. One is extremely heavy. One has a gold look to it. One has a red-brown streak, which is a diagnostic feature of that particular mineral. One marks on paper very easily. One has striations, and I'll show you what striations look like. And one has a firework smell. And then we have one that's dull, earthy, and smell. So that's kind of a hard one to do in a lab like this, is this smell, because we're not here to smell. We're not here to taste. So we're going to use all of these physical properties, and then next week we're going to identify minerals. And we're going to use these charts. So you are allowed to use these charts. We'll use these charts on the exam. So these 4 basic charts is what we're going to use. Sorry about that, I went to the wrong place. Chart number 1. Well, I'm in the wrong place. Chart number 1. I need a camera person. Chart number 2. Is that better? Chart number 3. And then chart number 4. All right, first let's look at color. So I went ahead and I recorded the colors of all the minerals. So number 1 is gray, 2 is black in color, and so forth. So I'm just going to go through and pan through some of these minerals, and just to give you an idea of the color aspects. So here, mineral number 1 is a gray color. There's also a magnet stuck on that, so that is a good indication that is a special property. Number 2 is black, very shiny. You can see the reflection in the light. Number 3 is kind of a red color. Number 4, kind of greenish black color. Number 5, about as white as you're going to get. Number 6. Number 7. Number 8. Definitely a gold look to that one. Number 9, a white color. This mineral here can vary in color. This particular one piece here has both blue and purple in it. The piece next to it's more of a green color, greenish blue. Goes to number 11, a gray mineral. 12, kind of an olive green color. 13, a white and gray color. 14, kind of like a transparent color, clear. 15, there's 2 different colors on this particular mineral. It can be either very dark or it can be very light. Number 16 is definitely a metallic mineral, silver look to it, very vitreous luster there. 17, also very silver looking color. 18, a deep red color. 19, a salmon pink color. And then 20. This mineral varies with respect to color. In fact, we name this mineral, we'll talk about this next week. We name this based on the color. All right, the next step would be the streak. So if we took every one of these minerals and ran them across the streak plate. So for example, let's look at number 17. This is a very unique property of streak for this mineral. So this mineral is kind of a silverish gray color, but yet when I streak that mineral, it gives a red-brown streak. The mineral right next to it is also silverish color, and yet when I streak that mineral, it produces a gray streak. So I went ahead and did a streak test for every one of the minerals here, and I recorded those answers on our lab. Sorry about the moving around so much, but I had to lay things out. So all the streak colors are right here. So number 1, a gray, slight brownish streak. And we all see things differently. They say males have a harder time seeing color than females, which may be true. All right, so the next thing to look at is the luster of these minerals. And there's 2 aspects of luster. The first we're going to look at is it dull, is it earthy, or is it vitreous? So vitreous is a word meaning shiny. So I recorded all of these. And then beneath it, I recorded if the minerals were metallic or non-metallic. So you can see by the circled metallics, very few of these minerals are metallic. So let's kind of look through and really quickly, let's look at the luster. So this one here with the magnet on it, I wonder what that mineral could be. Kind of has a dull look to it. Take the magnet off. Number 2, a little bit more of a vitreous luster, a little bit of shine to it. This one here definitely looks earthy. Kind of dull, little specks of shine. This mineral is kind of a strange one. On the cleaved surface at the top, it has a little bit of a shine to it, but the rest of it's kind of dull. This one should be the textbook example of earthy. It looks like dirt. It looks like almost like chalk. Very dull luster. Number 6, there's 2 different varieties of this mineral. It's the same mineral. And this mineral has a very vitreous luster, very shiny. You can just see the reflection of light in this particular, even in the black one. So you can see a nice reflection of light. Number 7, a very dull looking mineral. We put this in fireworks. This is sulfur. Number 8, brass yellow, very metallic though. So let's look at how many here are metallic in a second. So I'm going to go through all these real quick. And then number 9, a fairly shine to it, a little bit of vitreous. This definitely is vitreous. Number 11 has kind of a shine to it. 12 definitely dull. 13 as well, dull. 14 has a pretty good shine to it. And 15, these 2 minerals are pretty shiny, and this has a very special, unique property. You can almost see, especially in the dark ones, those straight lines, those are striations. We'll come back to striations. 16, this is metallic, very vitreous. Same with 17, another metallic, very vitreous. 18, about as earthy as you're going to get, very dull. Looks like dirt, looks like red dirt. Number 19 is pretty vitreous. You can see the shine. And then 20, these minerals are generally very vitreous. They're basically glass. All right, so all of these minerals, how many of these are metallic? Very few. Number 1 is metallic. It has enough iron in it that definitely makes it metallic. The next metallic mineral, we have to go all the way to number 8 before we find another metallic, and that is this one here, this gold color. Number 11 can be metallic or non-metallic. It's kind of one of those transition minerals. It's half metallic and half. It depends on the state sometimes. That's metallic. Then the next metallics, we have to go all the way to number 16. This is definitely a metallic mineral. Silver looking. And then 17 is definitely metallic. And that's the end of the metallics. So we've already looked at the aspects of color, streak. We look at the vitreousness, and we look at metallic properties. Now we know to look at hardness. So what I did is I went through and did a test on every one of these minerals. So the test is I see if A, will that mineral scratch my fingernail? B, will it scratch a copper plate? a piece of copper. Third thing I look at, will it scratch glass? And then fourth thing I looked at, will it scratch a file? Or will a file scratch it? So based on those tests, we can come up with a hardness numbers. Now these hardness numbers are in your sheet here. So at the beginning of the lab here, I give you a table. So your fingernail is about a 2.5 on the hardness scale of 1 to 10. So any mineral that does not scratch your fingernail is going to be less than a 2.5 on the hardness scale. Copper strips are about a 3.5. A glass slide is about a 5.5. So I had the liberty of scratching the glass slides and determine if the mineral easily scratched the glass slide or with the difficulty. And that's where I made a determination on some of these numbers of 5. So if you notice, the numbers do vary. These are pretty much true numbers. I'm pretty confident with these numbers. So you can basically pretty much say that these are the true hardnesses. So I went through and I did a hardness test for every one of these. The next thing I want to look at is the density, the specific gravity. So I took a sampling of the minerals, numbers 2, 3, 8, 11, 14, and 18. I weighed each sample out, so that's what that number 281.61 grams means. And then I calculated out the specific gravity. And the way you do that is you weigh the mineral on a scale. You then put it in a volume of water and see how much cubic centimeters or milliliters of water is displaced. You do the division of the weight versus the water displacement, and that gives you the specific gravity. So these specific gravities are dead right on. I went through them a couple times and made sure and double checked with the book on minerals, and these are pretty much on. And then notice that the one that weighs 190 grams, 190.23 grams is a very heavy mineral. And just to give you an idea of that, I'm going to go over here to the scales now. As soon as I detach myself from the cord. That was a detachment. And over here, I have a graduated cylinder with some colored water in it, and I have a scale. So interesting enough, I have two minerals here that are pretty close to the same size. So I'm going to put this white one on, this clear one on the scale first. I'm going to weigh what it weighs. So there it is, it's on the scale. And notice that weight. Okay, we had a little technical difficulty. Looks like a memory card crashed. So back to specific gravity. So I have two minerals that are pretty equal size. And I'm going to weigh these one at a time, and just to show you the difference in density. So here is this white one, clear one. It weighs 43.159 or 43.16 grams. Put the same size mineral on there. Make sure we go back to 0. This one weighs in 124.34 grams, or 124.341, and yet these two minerals are basically the same size, pretty close. So that shows that the gray color one has a higher density than the clear color one. How you do this is you start out with a known volume of water. So in this case I have a graduated cylinder. I put some blue water in it. I start out at 200 cubic centimeters. Actually, these are millimeters in this particular graduated cylinder. And then what you do is you put the mineral inside. You drop it down. Big splash. Wait for everything to settle out. You figure the volume, so you're going to take the volume of the mineral divided by the weight of the mineral, and that's going to give you specific gravity. So that's one of the things I did in this lab, is I definitely gave you specific gravities of these different minerals. So that's the other aspect that we're talking about, was specific gravity. And just to give you an idea, the one that weighs, in this case, 190.23 grams has a very heavy, very high specific gravity. And so we have two other things to look at, actually three things. We're going to look at crystal form, So these are the different forms of crystals that minerals can form. Then we're going to look at cleavage. And then last, the special properties. These are properties that are unique to this particular mineral. All right, let's look at crystal form. So I have here on the lab sheet a good representation of a lot of the different crystal forms that minerals form naturally. So if we look at the first one here, number 21, this definitely has kind of a hexagonal shape to it. So this would be a hexagonal prism, and that would be very well indicated by the hexagonal prism here. This next crystal is pretty unique. I mean, this is kind of a cool mineral. This mineral is forming octahedrons. So these aren't cut. These aren't polished. They're naturally occurring. So these are octahedrons. It's in the isometric class, which is the same crystal class as cubic. Number 23. This mineral is hexagonal. Again, a prism. And so that is the nearest shape that this mineral could form. All minerals would love to be cubes. This one here has such a complex chemical formula to it. It's calcium, magnesium, iron, potassium, silica, complex silicate. This forms little, what we call dodecahedrons. And these are all naturally occurring. So a dodecahedron, there's actually two types of dodecahedrons. There's one for every other mineral, and then pyrite forms a slightly irregular dodecahedron that we call a pyrohedron. Number 25 has a really simple shape to it. It's cubic. The preferred state in nature. And then last, this one really wanted to form a cube, but it couldn't. It came kind of close. So you can see that the cube is kind of offset. And this is the mineral class we call monoclinic. So that's monoclinic. Triclinic is very close, but this one actually is monoclinic. So there are the crystal forms. So this is another one of the steps that we use. The last two items we're going to look at today are cleavage. So I went ahead and circled all of the minerals that have cleavage. Let's go through our list here. Number 1, there's no cleavage to it. It's a fractured mineral. Number 2 does have cleavage. There are actually flat, shiny surfaces that form cleavage. Skipping to number 4, it has cleavage on one side. So wherever you see a flat surface and a shiny surface, notice that the other surfaces of this mineral are irregular. So cleavage sometimes will form on one side, sometimes multiple sides. Number 5, fracture. No cleavage, no flat surface, no shiny surface. Going down to number 8, this is a little tricky. You see crystals, and that's exactly what you see. If you were to hit this with a hammer, this mineral would fracture. So it grows crystals, but it fractures. So this does not have cleavage. Number 10, really good cleavage. Flat surface, shiny surface. So this is a mineral that definitely has cleavage. Moving on to number 11, basically fracture again. No cleavage. Moving to number 12, again, this mineral is fractured. No flat surfaces, no shiny surfaces, no cleavage. Going down to number 14, definitely cleavage. Look at that. This has multiple sides. In fact, every side of this mineral has cleavage. It has 4 different directions of cleavage. Actually, it has 3 different directions of cleavage. Sorry about that. So number 14, cleavage. Number 17, again, fractured. Moving to number 19, good cleavage. Flat surface, shiny surface, you can see the gleam, the shininess of that surface, number 19. And then last 20, this is definitely fractured. And again, this mineral sometimes grows nice little crystals. So when people see the crystals, they say, wow, that might be cleavage, but it's not. It's fracture. The last thing we want to look at is a special property. So on the bottom of this page here, I wrote out the specific property, and it's going to be hard to show all of these because of the fact that dull, earthy look and smell. How are you going to smell something off a video? You're not. So let's kind of go through. The one that has a rusty look to it is number 18. This looks like a pile of rust. And that's basically what it was. This was once iron ore that has been oxidized by oxygen. So number 18 has a rusted look. Number 1, going over here to number 1, is magnetic. And so here's a magnet. So number 1 here, you put the magnet on it and the magnet sticks. So number 1 is magnetic. Let's now go to has a salty taste. That's this mineral here. It's cubic. Anybody guess what has a salty taste? How about salt rock? Reacts to acid. So this is an interesting one. This is number 9. And so when I stick acid on this mineral, see how that fizzes and bubbles? Fizz, fizz, fizz. So that is the reaction to acid. Reacts to hydrochloric acid on a scratched surface. This is really hard to show. I've scratched some of the surface here on the corner, and you can barely see the acid. It's just really hard to illustrate on because of the darkness of this mineral. But number 3 reacts very slow to acid. Feels soapy. This is one of those things that's hard for me to tell. So number 13, if I rub this in my hands, I get definitely a soapy feel. So yeah, this is a soapy feeling. Actually, we make soap out of this. So 13, this is soapy feel. Very heavy. This is one weighed over in the scale. There's a lot of lead in this mineral. So this has the highest specific gravity, the highest density of any mineral here on this table. Looks like gold. That's pretty straightforward. We look at number 8. So sorry for the fast movement of the camera. So it looks like gold, number 8. Red-brown streak. So this mineral here is silver in color. And yet, number 17, when you streak it, it streaks a red-brown look. Number 16 is also kind of a silver look mineral. But when you streak it, it streaks the gray streak. So this is a diagnostic feature for this particular mineral. It has a red-brown streak. Marks on paper. Same stuff you find in your pencil. And so this is a mineral that easily, so look at number 11 here. I just made some marks by that mineral. Has striations. I think these will show up in the light. This mineral could be either gray or it can be silver. I mean, gray or white. And I think when I go back and forth, you can barely see some straight lines. That's what we refer to as striations. So striations are straight lines. This one has them too, but due to the light color, it's really difficult to pick them up with the resolution of this particular camera. Fireworks smell and a dull, earthy look. So the dull, earthy look and the fireworks smell. So this is one that smells like fireworks. This is what we put in fireworks. And I'll give you the name of this because it's not on our charts. It's sulfur. And then last, the dull, earthy smell. So this smells like right when rain starts to fall. Very dull, very earthy feeling, very soft. And so that concludes the minerals. So we're going to have a Zoom lecture on the minerals. And then in Canvas, you'll have specific questions about these mineral lab. So we'll end here.